When you open up the 45S case, you'll likely find it similar to mine, which includes the splicer, the CT50 cleaver, and the SS05 stripping tool. Additional accessories like the splicer's charger cord, a USB cable, and set plate for use with fiber holders or fuse connects are also included. The 45S comes with newly redesigned sheath clamps pre-installed, but it also provides SP04 set plates, 250 micron and 900 micron fiber holders as alternatives if you choose to splice using fiber holders. The splicer can be set up to match a wide variety of work styles and workflows. Voting time to set up will ensure that splicing remains the simple and quick process it should be. Following proper setup steps allows you to customize the splicer to align with your preferred workflow. Setup begins with determining whether you want to splice using sheath clamps or fiber holders. The newly redesigned sheath clamps are made to facilitate the dual fiber prep method, allowing you to load both fibers into the splicer simultaneously. By holding your fiber in place, gently pressing down on the rear of the sheath clamp, you can easily position the fiber and then close the clamp lid to secure your fiber in place. When using this method, you'll also have the option to synchronize the sheath clamps with the wind protector's opening and closing motion. Flip the switch on either side of the wind protector to engage or disengage each clamp. When engaged, the clamp opens whenever the lid is open and closes whenever the lid is closed. With the sheath clamp linked to the wind protector, it's important to note the inclusion of the secondary fiber retention clamp, a feature previously only seen in the universal sheath clamp of the 90S Plus. When in use, the secondary fiber retention clamp remains closed when a sheath clamp is open, flipping up and out of the way once the splice is lifted. This keeps your fibers under control, so when you're finished with a splice, you don't need to worry about damaging your unprotected splice. If you're working with 900 micron type buffer coated fiber, strip off the outer coating in short 1/4 inch pieces. Afterwards, use the smallest hole of the stripper to remove any remaining 250 micron subcoating. If you're using 900 micron loose tube or furrication tubing, you will need to swap out your standard sheath clamps with loose tube compatible sheath clamp. Clamp S35B loose buffered sheath clamp. These clamps have a protrusion that securely holds fibers within its furrication tube, preventing sliding around as the splicer handles it. Employing the correct sheath clamp with loose tube fiber helps avoid motor overrun errors. Alternatively, the fiber holders, also referred to as chucks or sleds, offer a user-friendly option for handling fiber, allowing for a more substantial object to grip. To splice using this method, you need to transition from the factory setup by 1. Removing the sheath clamps from the splicer. 2. Installing set plates in place of the sheath clamps. And 3. Removing the adapter plate from the cleaver. The AD16 adapter plate has the same size and shape as the fiber holder, so removing it allows you to load a fiber holder directly into the cleaver. Each fiber holder has a magnetic lid to hold the fiber in place, along with 2 guide holes to align the fiber holder on the guide pins of the installed set plates. Once your setup is complete, load the fiber into the fiber holder with about 30 millimeters or 1 1/4 inch of fiber extending from the end. Strip the coating off the fiber, clean, sleeve, and position the fiber holder onto the guide pins to secure it in place. Splicing with fiber holders enhances ease of use and minimizes handling errors during the splice. Once loaded into the fiber holder, the fiber doesn't need to be removed until the splice is finished. This ensures consistent cleave length each time, and the fiber's end consistently lands in the same position in the splicer. The next step in the setup involves selecting the operation settings that match your workflow. Keep in mind that these settings can be adjusted at any time, so feel free to experiment with different options to determine what works best for you. Power on your splicer and navigate to Home, then Splice Settings, then Fundamental Settings. Within the Fundamental Settings menu, you can toggle the pause settings and the auto start settings. 1. Turn pause on to have the splicer pause after completing fiber alignment. This allows you to inspect the preparation quality of the fibers before they are spliced together. 2. Turn on the auto start trigger setting to either on or off based on your preference and level of automation you want in your splicing process. The last step of the setup process involves conducting an arc calibration. Select the shortcut to access the arc calibration function. Prepare 2 standard single mode fibers as if you were going to splice. Load them into the splicer and press the play icon to start the process. This only takes a few seconds and is not only integral to the initial setup, but should also be performed at the start of each day to keep your splicer running at peak performance. When utilizing the 45S alongside the CT50 cleaver, you have the added option of using active blade management. This feature uses Bluetooth communication between the splicer and the connected cleaver to control the cleaver's blade position. When it detects a certain number of consecutive bad cleaves, the splicer can command the cleaver blade to rotate. Paired with proper cleaver maintenance, this function alleviates the need for manually keeping count of cleaves of each blade position, as the splicer keeps count for you. Navigate to other settings and enable it in the Bluetooth settings menu. Then fine-tune cleaver-specific parameters in the cleaver settings menu. There's also a shortcut to Bluetooth settings on the right-hand side of the home screen along the upper edge. When using this feature, the splicer relies on statistical analysis logic to keep track of cleaves during the dual fiber prep method, since one cleaving action simultaneously cleaves 2 fibers. The 45S comes equipped with active fusion control and Warren Splice imaging, optimizing your splice outcomes. With active fusion control activated, any cleave angle between 3 and 5 degrees triggers automatic adjustments to the arc parameters. This feature minimizes splice loss effects associated with large cleave angles. Warren Splice imaging, WSI, is an algorithm that analyzes the image of the fibers during the melting process, capturing more information about their alignment. As the fibers are heated by the arc, the core tends to glow brighter than the cladding. Analyzing the Warren Splice image allows the splicer to make significant improvements to estimation accuracy compared to what is typically achievable with a cladding alignment splicer. Once your machine is set up, choose a splice mode that corresponds with the fiber type you'll be working with, and select a heater mode that corresponds with the shrink sleeves you have. In this case, I'm using 2 standard single mode fibers, so I'll use the SM Auto as my splice mode. Choosing the right splice mode is a crucial factor to successful splicing. Be sure to identify the fiber type you're using and choose the splice mode that corresponds with the fiber at hand. For example, if you're splicing single mode fiber to single mode fiber, you'll likely start with an SM Auto, SM Fast, or SM to SM. Similarly, when splicing multi-mode fiber to itself, you'll likely begin with choices such as MM Auto, MM Fast, or MM to MM. Any splice mode with the word Auto after it will monitor arc power with each splice, making minor adjustments from one splice to the next. This helps maintain accuracy in arc calibration as environmental conditions change throughout the day. It's important to note that this isn't a substitute for daily arc calibrations. Factors like temperature, barometric pressure, and humidity impact the required arc power for precise fiber melting. Since conditions can vary daily, start the day with a quick arc calibration and then use a splice mode ending in auto to keep the initial calibration's accuracy as conditions evolve throughout the day. Splice modes with the fast suffix will assume the correct fiber type is loaded, adopt the most recently calibrated arc power value, and perform the splice in as little time as possible. Splice modes without a suffix after the listed fiber types are categorized as special modes. These modes have an extended parameter list that you can customize for your splice recipe. Choose one of these modes when working with a special fiber type, or if you need to adjust certain parameters. Choosing a heater mode is fairly straightforward. In most cases, single fibers are protected with 60 millimeter, 40 millimeter, or Fuse Connect protection sleeves. However, heating profiles are also available for other types of protection sleeves. After selecting your splice mode and heater mode, prepare the fibers for splicing following the acronym SSCCL, which stands for sleeve, strip, clean, cleave, and load. Sleeve. Slip a clean protection sleeve over one of the fibers you're about to splice. Strip. Use hand strippers or thermal stripper to remove the protective coating from the fiber. If applicable, load the fiber into the appropriate fiber holder before stripping. Clean. Wipe the exposed glass with a fresh, lint-free cloth moistened with either FCC2 fluid or 99% or greater isopropyl alcohol. Cleave. Load the cleave fiber into the cleaver, fully raise, and gently lower the cleaving arm to cleave the fiber. Remove the fiber from the cleaver before you're returning the cleaver arm to the ready position. Load. Immediately after cleaving, load the fiber directly into the splicer without placing it on any other surfaces. Placing the fiber down anywhere increases the risk of getting dust or dirt on the cleaved end of the fiber and the V-grooves of the splicer. Never clean a fiber after cleaving. It might be counterintuitive, but this will actually deposit more contamination onto the cleaved end of the fiber. Developing good, consistent fiber prep habits would not only be appreciated by your equipment, but will also be reflected in the quality of your splices. Once the fibers are loaded in the splicer, visually confirm the position of the fiber ends. Ideally, they should both land about halfway between the inside edge of the V-grooves and the center line of your electrodes. Close the wind protector. After this stage, depending on your operational settings, the splicer might start automatically, or you may need to press set or play. Unless you activated any of the pause options, the splicer will seamlessly progress through the entire process. You'll see the fibers come together, be inspected by the splicer, and be spliced together. Gently remove the splice fibers from the splicer and use the positioning feature on top of the heater oven to place the shrink sleeve over the splice. If you're using sheath clamps, there's an additional positioning feature. Grab the fiber opposite the protection sleeve at the edge of the sheath clamp. Grab the protection sleeve side and lift the whole splice out of the machine. Then tilt the fiber to center the sleeve over the splice point using your fingers as a positioning stop. After aligning the sleeve, hold tension on the fiber and lower it into the heater oven. Fiber splices have excellent tensile strength, so there's no need to worry about breaking the splice. Hold the splice in the position until the heater elements secure the splice protector. Releasing too soon might cause the sleeve to fall beneath the heating element and not shrink correctly. When the heating cycle is finished, lift the protected splice from the oven and allow it to cool off. Be careful as it will be hot, and wait a minute or so before touching it. The splicing and heating functions of the machine operate independently of each other, so you're able to begin the next splice as soon as the heating cycle starts. Now that the splice is finished, take some time to practice with a few more splices, experimenting with different operational settings. Getting to know your equipment is key to future splicing success. The better you know your machine, the easier it will be to recognize issues and keep yourself up and running. The 45S is a precision calibrated machine functioning within exceptionally narrow tolerances. By spending time reading your instruction manual, following recommended procedures, and maintaining regular cleaning and upkeep, your equipment will thank you and the quality of your splices will be clear.